Hey everyone. This is going to be a quick lesson on, or I should really say brief, a very brief lesson on chapter 5. And as you could see, I bundled it in with chapter 6. So the heading of this next worksheet, set of notes, examples, is chapter 6, random variables and discrete probability distributions. But I did insert chapter 5 just in the first page. So if you were to look in the book, in the text, chapter 5 is a meaty section. There's a lot going on in chapter 5. We don't cover it all in this course. This is an introduction course. So really all you guys need to know is the basic classical probability definition for equally likely outcomes. And that's going to help us in chapter 6 and chapter 7 when we have to calculate probabilities. So as long as you know how to write probability notation and you understand the important characteristics of the probability of an event and how to, like I said, and how to calculate a basic probability for equally likely outcomes, you'll be fine moving forward. So whatever's on this first page here, this is all you're responsible for chapter 5, and it's going to be useful moving forward. So probability, you guys have definitely heard the word probability before, not even necessarily in a math class, right? There's things in real life that we encounter that has to do with probability, and we'll talk about some examples. But probability, think of it as the likelihood that a particular event will happen in the future. And the way we write probability could be either as a decimal, a fraction, or a percent. So let me give you some examples where you might encounter probability on a daily basis. So how about the weather? That's one of the things that I always think of first, right? So on your phone, you have a weather app. And if you were to open the weather app and look at tomorrow's weather, there's going to be a percent chance of precipitation, right? A lot of times, one of the first things you'll see when you're looking at the weather is precipitation and then the percent, right? And that's the likelihood that it's going to rain, right? Or have some sort of precipitation that day. So let's say your app says there's a 10% chance of rain. How do you interpret that, right? Are you going to bring an umbrella, wear a hood, bring a rain jacket? Probably not at a 10% chance, right? But if it said there's a 90% chance that it's going to rain, I would probably bring my jacket and umbrella because that's very likely. You have to think of it this way, right? If something's going to happen definitely in the future, then there's 100% chance, right? The probability would be 100% that it must occur, right? And then what if it's not possible? It can occur. Then we would say the probability is 0%. So a probability could be any value between 0 and 100% inclusive. And if we write that as a decimal, 0 to 1. And we could also write of probability in fraction form as well. But I think for the most part in this course, when we calculate probabilities, we're going to leave it in decimal answer, a lot of times to 4 places. And we'll practice that. So just think of probability as the likelihood that a particular event is going to occur or not occur for that matter in the future. So here's our classical probability definition for equally likely outcomes. So if we have an event, which we'll call it E, an event could be anything, rolling a 4 when you roll a fair die, rolling a tail when you or flipping a tail when you flip a coin once, picking the number 10 out of a hat if there's cards numbered 1 to 10. So an event is just, out of the total number of outcomes, the event that you're interested in is going to have a particular characteristic. So the way we write the probability of some event E is like this, P, and then in parentheses, event E. So think of that P as standing for probability of, and then whatever's in the parentheses, that's what we're trying to calculate the probability of. So in this case, the probability of event E. And we'll practice with probability notation in the example below. So whenever we have an event that has outcomes that are all equally likely, like tossing a coin, rolling a die, right? Because when you roll a die, there's 6 sides on a die and they're all equally likely. When you flip a coin, you could either get heads or tails, right? And both heads or tails have the same chance of occurring. So we call that an equally likely process. So the way we find the probability of an event E when there's equally likely outcomes is we take the total number of outcomes that are in the sample space, and a sample space is just a list of all the possible outcomes, and I'll write that down. So a sample space is a list of all possible outcomes of an experiment. So that's always going to go in the denominator. And then in the numerator, we would put the number of outcomes that satisfy event E. And we're going to do some examples. Before we get into example 1, I just want to point out these 2 important bullets here. The probability of an event always has to be between 0 and 1 inclusive. It's not possible to have a negative probability, and it's not possible to have a probability that's greater than 1 or 100%. And then if I were to sum up all the probabilities of all the outcomes of an experiment, so of all the outcomes in the sample space, that sum will always equal to 1. So for example, when I flip a coin, there's 2 possible outcomes, right? Heads or tails. Each one has a 50% chance of occurring, or 0.5. If I were to add up the probabilities for both those 2 different outcomes, 0.5 plus 0.5, that's equal to 1. So that's what I mean when I say the sum of the probabilities of all the outcomes in the sample space of an experiment, they always have to equal 1. So let's look at example 1. Find the probability of each of the following events, and let's practice using probability notation. So what's the probability of rolling a fair die and a 4 appearing? So another way that we could write this, rather than writing out all the words, we could say, what's the probability of, and then a 4. You could put the word appearing if you want, but I would just write this as the probability of getting a 4, just like that. So let's use this formula that we have up here. First, you have to ask yourself, how many outcomes are possible when you roll a fair die? And a fair die has 6 sides. So the denominator is going to be the total number of possible outcomes in the sample space, which is 6, right? So we could even list them: 1, 2, 3, 4, 5, and 6. Now in the numerator is going to go how many outcomes satisfy the event, right? So in this case, the event is a 4 appearing. How many of these outcomes are a 4? Just 1, right? Just 1 out of 6. So that would be our probability in fraction form, 1 out of 6. And we could divide that out. If we divide out 1 by 6, we're going to get 0.1666667. So this is about 0.1667, which is about, if we wanted to write that as a percent, 16.67%. So those are the 3 different ways that we could write a probability answer. Let's look at B. What's the probability of flipping a coin and then a tail appearing? So what's the probability of a tail? Well, when we flip a coin, how many possible outcomes are there? There's 2, right? Heads or tails. So that's going to go in the denominator, 2. How many outcomes? And when we flip a coin, there's only 2 possibilities, heads or tails. That's it. And how many of them happen to satisfy being a tail? Just 1. So it's going to be 1 out of 2, or 0.50 or 50%. Let's look at part C. What about flipping a coin once and an even number appearing? And I think this is supposed to be rolling a die. So let's fix this. I just realized there's a typo. So instead of flipping a coin, because when you flip a coin, there's only heads or tails. So rolling a die, this should be rolling a die once and an even number appearing. So here's my possibilities: 1, 2, 3, 4, 5, and 6, right? When I roll a die. So the probability of getting an even number is going to be equal to something out of 6, right? Because there's 6 possibilities. Now you have to ask yourself, how many are even? So we have 2, 4, and 6, right? Those are even numbers. So it's going to be 3 out of 6 or 1/2, right? We could write that as 0.5. Let's look at part D. What's the probability of randomly selecting the incorrect answer to a 4-choice multiple choice question? So what's the probability of getting the answer incorrect? So imagine you have a multiple choice question and there's 4 choices. So you could pick A, B, C, or D. So out of the 4 choices, right? So that's how many outcomes are in my sample space. How many of those are incorrect? Now, typically when we have a multiple choice question, just one of them is the correct answer, right? The other 3 are the wrong answer or the incorrect answer. So that's going to be 3 out of 4 or 0.75 if we convert that to a decimal. And then let's just practice one more, and then I think we'll pretty much have the hang of it. And then we're going to incorporate this into chapter 6. So E says, what's the probability of selecting a red ball from a bin containing 4 white, 2 red, and 6 yellow? So how many are there all together? So all together there's 12. 4 plus 2 plus 6. So there's 12 possibilities in my sample space. Now, how many of them satisfy being red, right? How many have that characteristic? And there's 2 red, right? So it's going to be 2 out of 12 or 1/6, right? If we were to reduce that and if we were to write that in decimal form, it's going to be about 0.1667. So this is an example of basic probability, classical probability when we have equally likely outcomes. And we're going to incorporate these concepts into chapter 6, and we'll start chapter 6 in the next lesson.